All right, so guys, let's do a review of what we were doing Tuesday night. We had already done 7-1. We did half of 7-2. And it's being recorded right now. Don't you worry, none. Don't you worry, Miss Haley. All right, so look, it's recording right now, guys. 7 point. Look, let me make sure. Right? There we go. Okay, okay. So we know it is, right? Okay. So, guys, one of the things we were talking about. I'm going to try to clean up a little bit of this mess here so it's not so messy. And so one of the things that we were talking about on Tuesday night was how do we know when we're going to reject the null hypothesis or the HO, right? Or how do we know we're going to fail to reject it, okay? So guys, one of the things that we were looking at here was we were looking at the p-value, right? The probability that we have compared to our alpha, okay? So in the first problem that we did on Tuesday night, guys, it told us right here, okay, here was my p-value, right? Our p-value is 0.0237, right? Remember, I was telling you, think about it in terms of money, right? In terms of money, this would be a little bit more than how much? Think of money, guys. A little bit more than 2 cents, okay? What is our alpha in this case? In terms of money, 5 cents. Okay, so all I'm really doing here, guys, is I'm going to do a comparison, okay? When P is smaller than alpha, smaller than or equal to alpha, I'm going to reject it. If P is bigger than alpha, then we're going to fail to reject it, okay? So look, here's our P number, 2 cents. Our alpha is 5 cents. Is P smaller than or equal to alpha, or is P bigger than alpha? Is 2 cents smaller than or equal to 5 cents? Smaller than or equal to, right? So then that's what we said we were going to, and I wrote it right here, but it looks pretty messy, so let me clean this up. Okay. That's what we said in this problem. We were going to, that's right, we were going to reject the null hypothesis, right? Because our P number happened to be smaller than the alpha, right? And then when we did the part B, we're still dealing with that same P number, right? We're still dealing with about 2 cents here. Look at my alpha now. My alpha is 1 cent. Is 2 cents smaller than or equal to 1 cent, or is 2 cents bigger than 1 cent? It's bigger, right? So because it was bigger, and it tells me right here, when P is bigger than it, then we decided to do what? Fail to reject, right? So that's what I was looking at. I was looking at those numbers there, right? Okay, and then the second part, I'm just going to kind of scooch over here, guys. Let's see, the second part said finding the p-value for a hypothesis test. Okay, so it told me that when our test was going to be a left tail test, the p was going to be the area in the left tail. When we had a right tail test, it was going to be the area in the right tail. And if we had a two-tail test, it was going to be twice the area in the tail of the standardized test statistic, okay? So let's see if we can sort of make sense of what that means in terms of this first problem, number 2. Yeah, I'm going to give you all the stuff that you need to know. Don't worry, we'll get there when we get there, okay? So let's take a look here. It says, find the p-value for a left-tailed hypothesis test with a test statistic of z was negative 2.23. Decide whether or not we should reject the null if the level of significance is 0.01. Okay, so guys, what we did first off, we said, look, let's look at our picture right here, right? Oops, wrong one. Let's look at our picture right here. We put our z value to be negative 2.23 because this is a, let's see, this is a left tail test, right? Doesn't it tell me right here it's a left tail test? Right? Then we're looking for the area in this little piece, right? So does anybody remember how we found that area using that z value of negative 2.23? Do you remember what we did? Okay, so we turn on our calculator, right? I'm going to just scooch it over here. We turned it on, and it's on. Okay, so then we went second bars. And guys, because we're trying to find the area, right? Didn't we go normal CDF? Right? And what's the boundary all the way over here to the left? The negative with all the 9s, right? Okay. And then didn't we stop at a negative 2.23? Okay. And if you look here, let's see. I think that's the p-value. And didn't we write it down right here? 0.0129? Because we rounded it to 4 decimal places, and since to the right of that is a 7, we rounded it up to a 9? Okay. Once we did that, guys, all we did now was we said, look, let's compare our p-value again to our alpha, okay? So I want to think about this number. Look, this is a little bit more than 1 cent. This is exactly 1 cent, okay? Is a little bit more than 1 cent bigger? Yes, it is, right? And if it's bigger, what did we say? Come back over here. Fail to reject, right? And that's why we wrote right here, we were going to fail to reject, right? Did that make sense? Okay. And then for number 3, didn't we do the same thing on number 3? Exactly the same thing, because what kind of test was number 3? Still, oops. It was still a left tail test, right? So didn't we do this problem exactly the same way, right? Didn't we say, look, here's my z-value, right? So our z-value was negative 1.71. So didn't we go normal CDF, negative all the 9s, all the way up to negative 1.71 so we could find our p-value? And then we compared our p-value to our alpha. And again, if we think about this, this is a little bit more than 4 cents. This is exactly 5 cents. So 4 cents is smaller than or equal to 5 cents. And then, guys, I think I had also given you this handout. Those of you who, I'll get it for you in a little bit. But here we go. All I did is just kind of put this so it, a little bit more clear or whatever. But when P was smaller than alpha, we reject it. When P was bigger than alpha, we failed to reject. Since P was smaller than, then we decided to what? Reject it, right? And if you notice right here, boom, there it is. We rejected the H0, we rejected the null hypothesis, right? Okay. So guys, then when we did number 4, let's see, we came up with a z of 2.14, right? So because this is a two-tailed test, right? Because it tells you right here, two-tailed. So when we did our two-tailed test and we found the area that way and we found the area that way, how did we get this p right here? We added them both together, right? Or we doubled it, right? And that's how we came up with our p. Did exactly the same thing. Since our p was smaller than or equal to alpha, we decided that we had to reject the null hypothesis, right? That's right. That's how I get my p-value. When it's a two-tailed test, once I find the area here and I find the area there, I'm just going to add them up. And that's how I'm coming up with that number right there. If it's just left or right, you're just going to take that. You don't got to do anything with it, right? But if it's a two-tailed test, you're really looking for both of those areas together, right? All righty. And then, guys, we use these, right? We use the formulas right here, right? And when and I'll kind of go through it a little bit, but the first thing we really had to do was figure out what is our claim, right? What is our claim? So when we did, let's just do number 5. Let's go through number 5 again, and then make sure that it all makes sense. So let's take a look. It says at number 5 in auto racing, a pit crew claims that the mean pit stop time is less than 13 seconds. Okay, so guys, it told us right here that the mean, which was our mu, was less than 13, right? That happened to be our claim. And we said, what's the opposite of saying something is smaller than 13? It would have to be bigger than or equal to, right? Okay, so, all right, it would have to be bigger than or equal to. All right, and then we decided because this one had the equal to, that had to be our what? You remember what this is called? Our HO, right? Our null hypothesis. And so then the alternate would be the one that just had the strict less than, right? Okay, so let's see. Guys, from the problem it says we had 32 pit stop times, so we knew that our n was 32. And the sample mean, which was our x bar, was 12.9. And our sample, let's see, our population standard deviation, our sigma, was 0.19, right? So guys, all I did was I took those pieces of information and we plugged them into the formula right up here, right? So we said, look, let's take that x bar minus the mu divided by sigma divided by the square root of n. And so when we did this, remember how we did this on the calculator, guys? Let me bring this guy up and let's pull it over here. Maybe there we go. Okay. Okay, before I do that, how do I do this? This is a question I'm asking you. How do I do this? There you go, 12.9 minus 13, okay? Negative 0.1, right? And then when we did divided by, what do we have to put? Parentheses. So guys, if you notice, I even wrote them here. So we put parentheses and we put 0.19 divided by the square root of, what was our n in this case? 32, okay? And then close the parentheses, right? Twice, right? Boom. Okay, the reason we're closing them twice because my calculator opens up one right there. And then when we hit equals, we rounded this number to 2 decimal places, so we came up with our negative 2.98, right? Now guys, notice what we did. I'm just going to bring my calculator down for a little bit. Right now, we just found the z-value, right? So just like we had done on earlier, we said, look, if this number right here is negative 2.98, how would we find this area? Well, then we're going to go back and do our normal CDF, right? So clear it out. We're going to go second bars, normal CDF. And guys, because this is a left tail test, where am I all the way over here? Negative with all the nines? Okay. And then we stopped at what number? Negative 2.98, excellent. Nobody, I could have stayed home. And look at the p-value we got. The p-value we came up with is 0.0014, and that's what we wrote right here, right? And then once we got that value, all we had to do now was compare it to the little funny looking A, right? To the alpha. And we said, look, if you were to think about this in terms of money, is that even a penny? No, it's not even a penny. But this one is, right? So since this number is smaller than or equal to, when the p-value, when the p-value is smaller than, let's see, when it's smaller than, then we're going to reject the null. So we said, okay, we're going to reject the null, right? Which we put right here. And then guys, the second part we had to figure out is, okay, well, what does that mean now? Which one of these two was our claim? Was it the HO or the HA? The HA, right? So in that other handout, I said, look, when my claim is the HA, which is right here, right? The claim is HA, and we decided to reject the null. We're going to say there's enough evidence to support the claim, and if you notice right here, there is enough evidence to support the claim that, and we just said what the claim was, right? The mean pit stop time is less than 13 seconds, right? And that was what we ended up doing. Okay. And then, didn't we also do this problem using our calculator? Right? And we were like, oh man, why didn't I do it like that the first time? I said, well, I don't know. I don't know why we didn't do it like that the first time, but let's do it like that now. So look, we're going to come over here. We're going to go to stat, right? We're going to go to tests. And because, guys, so the one time, or one of the questions people often ask is, look, there's a whole bunch of tests here, right? Which is the one that I use? When they give me the population standard deviation, I'm going to use the z-test, okay? So I'm going to hit enter, right? And then we're going to go, first thing we're going to do, we're going to go to stats. Over here on the right, I'm going to hit enter again. Okay. So right here, the mu, what's the mu number that they're claiming? 13. So we're going to type in 13. Okay. And our population standard, our sigma, what was our sigma number? 0.19. And our x bar, what was our x bar number? 12.9, right? Boom. Okay. And then our n, what was our n in this case? 32, right? Okay. And then we have to figure out, is this a left tail test, right tail test, or two tail test? Guys, do you remember how would I know? Which is the one that I look at? Okay, but hold on. My question is, do I look at this one or do I look at this one? Okay, we always look at the HA, guys. Okay, not necessarily that we always look at the claim, but we always look at the alternate, right? The one that has the ha. Okay, and because that's pointing to the left, ha. Then we're going to go here, enter, okay? And then we go to calculate, enter one more time. And let's see. Guys, look at the z-value here. Negative 2.98, if we round it. Right, boom, there it is, right? Look at our p-value, 0.00114. Boom, there it is right there, right? And then you can just compare it to the alpha, right? So the calculator does everything, ¿verdad? Everything. So the only thing I would ask you to do is probably write out, okay, like what's your N, what's your X bar, right? What's your sigma, you know what I mean? Write down some of those basic pieces of information and then just tell me, again, remember how we did on the second test? And you would write like binomial PDF or you wrote binomial CDF and you did whatever you have to do. I'm gonna ask you to do the same kind of setup here, right? That's right, so that you know which one you need to do, and that when I'm grading your test, I know, like if you come up with the right answer, then we know we're good, right? But if you come up with something that's off, I want to know where did you like make your mistake. You know what I mean? Alrighty. So, guys, I'm going to kind of scooch down. We also did this problem here, and then this kind of showed us how to do it on the calculator. Okay. So, we're going to do the same types of problems that we were doing on Tuesday night, just slightly different, okay? This is still 7.2, right? We just hadn't finished it off the other day. Okay, so what we're going to do here, guys, we're going to talk about these things called rejection regions and critical values. So it says a similar way to decide whether to reject the null hypothesis is to determine whether the standardized score or the z-score falls in the rejection region of the sampling distribution. Okay, so it says here, a rejection region or a critical region of a sampling distribution is a range of values for which the null hypothesis is not probable. If a standardized test statistic falls in this region, the null hypothesis is rejected. A critical value Z0 separates the rejection region from the non-rejected region. Okay, so the way we're going to do this here, it says finding critical values in a normal distribution. We have to specify the level of significance, the alpha. Decide whether the test is a left, right, or two-tailed test. We're going to find the critical values, okay? And so I want you to look right here, and it tells me exactly how to do that part. Boom, boom. Okay, so it says if it's a left tail test, find the z-score that corresponds to an area of alpha. If it's a right tail test, find the z-score that corresponds to an area of 1 minus alpha. And if it's a two-tailed, find the z-score that corresponds to half of alpha and 1 minus half of alpha. Okay, so sketch the normal standard distribution, draw a vertical line at each critical value, and shade the rejection regions. Okay, so let's take a look at the first problem, see if we can't figure this thing out. Oh, buddy. Okay, all it wants us to do is find a critical value, Z0, in a rejection region for a left tail test with alpha being 0.01. Okay, so guys, what we're going to do, we're going to find a z-score, okay? We're going to find the z-score when the area to the left, because this is a left tail test, in this case happens to be 0.01. So all I want to do is I want to find my z-score that corresponds to that, right? So guys, we've done this before, right? I'm going to grab my calculator. So if I'm trying to find the z-score, I'm trying to find the z-value, when I know the area to the left is 0.01, don't we go, let me see, move this a little bit, don't I go second vars, and then don't we go inverse norm? And what's the area to the left? 0.01, 0.01, okay, close it off. All right, and what's the z-value that we came up with? There you go, negative 2.33, okay. All right, what this is going to tell me, guys, is that, let me clean up this little thing right here, and let me write that number that we came up with, negative 2.33. Okay, what this tells me, anything that falls in this region is what we call the fail to reject region. And anything that falls over here on this side is going to be our rejection region. We're going to reject the null, the HO. Okay. Yes, sir. Of that one, right? Now let's see if we can do the same thing for number 8. It says find the critical value Z0 in a rejection region for a two-tailed test where alpha is 0.05. Okay, so guys, I want you to notice right here, it tells me what happens when we have a two-tailed test. If we have a two-tailed test, we're going to find the z-score that corresponds to half of alpha and 1 minus half of alpha. So first question to you is, what would be half of alpha? What's half of a nickel? 0.025? Okay. Okay, so the area here is going to be 0.025, and the area over here, 0.025, okay? All right, so now what we're trying to do, find this area, find that area, okay? So my first question, how would we find our z values? Okay, so we're going to come back here, we're going to grab our calculator again. We're going to go inverse norm. Here we go. And 0.025. Okay. And are you coming up with negative 1.96? Okay. So guys, what that's telling me is that this one right here is a negative 1.96. What do you think this one would be? Positive 1.96, right? Okay. So guys, just like we did earlier, the piece in the middle, and I'm going to kind of abbreviate just because I don't have a lot of room, failed to reject the null hypothesis. And this area here and this area here are going to be our rejections. Ah, look, I got a little ahead of myself. Because isn't that what we have down here? Right? The same kind of setup, right? So if you look at what we had in this picture right up here, isn't that the same thing right here, right? And the one we just did right now is this one right here, and if we had a right tail test, that's what it would look like, right? Okay, so let's see. Let's see if we can do a problem here. Okay. Grab my pen, okay? So it says, employees at a construction and mining company claim that the mean salary of the company's mechanical engineers is less than that of one of the competitors, which is $68,000. Okay, so let's read that first part of the sentence again and see if we can figure it out. It says, the mean salary, okay, so the mean salary, guys, remember that's our mu, right? Is what? But is it equal to 68,000? Why equals? But what does it say right here? Less than, ¿verdad? Less than 68,000. Okay. Everybody agree this is our claim? Right? Because that's what they're claiming? Okay, so guys, what is the opposite of saying something is less than 68,000? Greater than or equal to 68,000, right? Okay. Now that we have that, okay, my next question to you, which one is our HO and which one is our HA? The bottom one is HO? Okay, and this one here is HA, right? Okay, so guys, just a quick reminder, how do we remember which is the HO? The HO is always going to have what sign? The equals, right? Okay, good. All right. Now, let's see what else we know. Let's see, it says we have a random sample, so my N was 20. Okay. Let's see, has a mean salary, so my X bar is 66,900. Okay. And we know our population standard deviation was what, 5,500? 5,500. And our alpha is going to be 0.05, so I'm going to just write it right here, 0.05. Okay, so guys, my first question to you, is this going to be a left tail test, a right tail test, or a two tail test? Okay, so let's make sure, it's okay, let's make sure we understand. I'm glad that, if you don't know guys, that's okay. Let's figure out, how do we know? The ha. It's always going to be the HA. The HA, whether it's the claim or whether it's not the claim, the HA is always going to tell me, right? And what I have to do is I have to look at the way the arrow points. So which way is the arrow pointing? To the left, right? Okay, to the left, right? All right, so everybody agree that the area is over here? Okay, so guys, remember a little while ago, if I said, can we find, should I give myself a little bit more room? Can we find that Z0 value? We just did that right now. What did we do to find that Z0 value? We got our calculator, right? And what do we do to find the Z value when the alpha is 0.05? Do you remember what we did? So we went over here, second vars, right? We came inverse norm. What's the area to the left? 0.05, okay. And I'm gonna hit enter. Okay, so the Z value that I'm coming up with, guys, if I round to 2 decimal places, negative 1.64 or 1.65? 64, okay. So I'm gonna write it right here, negative 1.64. Here we go. Okay, now what I want us to do is we're going to find our Z value like we did in the problem that we did a little bit earlier, the same one that we did on Tuesday night. All right, so let's see if we can do this part here, guys. What is our X bar in this case? 66,900? Minus, what is our mu in this case? 68,000, right? Now, I'm going to come back over here. What is my sigma? 5,500 divided by the square root. What was our n? 20. Okay, so guys, remember what we're doing now. We're going to grab our calculators again. Okay, what should we do first in terms of our calculator? Yeah, turn it on, right? For obviously, step number 1, boom, make sure it's running, right? Good. Okay, then what? What are we going to do first? What's the first calculation? Subtract them, right? 66,900, let's see, minus 68,000. There we go. Has I got on my numbers? Yeah, I think so. Okay, negative 1,100. And then we're going to go divided by, what are we going to put? What's the first thing we got to put? Okay, before I do 5,500 though, open parentheses. Okay, don't forget the parentheses, guys, because your calculator will calculate slightly different, right? Divided by, don't we got to go second square root? 20. And then close the parentheses, how many times? Twice, right? Okay, boom, let's see. Look at the Z value we came up with. Negative 0.89, right? So right here, guys, I'm going to write the number negative 0.89. Okay, so far are we okay on how we came up with what we came up with? All right, now guys, I'm going to zoom in a little bit. Okay. My question to you, let's get a different color, let's go green. Okay, my question to you, where would I put 0.89? Would I put 0.89 to the left of this number or to the right of that red line? Where do you think negative 0.89 would go? Let's see. So think about it this way. Forget, do me a favor. Forget about negative 0.89. Suppose I was going to put the number 0. Do you agree that somewhere 0 would be right here, right? Somewhere in the middle, right? As we know, that's where it goes. Now, where would 0.89 go? Would it go between those two, or would it go to the left where the red is? Between these two, right? Wouldn't somewhere right here be 0.89 with a negative? I'm sorry. There we go. Negative 0.89, right? And that's what we had here, right? I forgot to put it too. Sorry. Thank you. Okay. Now, guys, remember what we said earlier? If I come back and I look at, here we go. Let me get rid of the yellows so that we can see it. What region did we fall in? Fail to reject. So all I'm going to do right here is I'm going to say we fail to reject the null hypothesis, right? Fail to reject the null hypothesis. Now, guys, now that we know we're going to fail to reject the null hypothesis, then we got to figure out what are we going to conclude, right? So let's think about this for a minute. I'm going to pull up the other part right here. Okay, so we're going to fail to reject. So we know that we're going to either look at this one here or we're going to look at this one over here. Okay, we're either going to say there's not enough evidence to reject the claim, or we're going to say there is not enough evidence to support the claim. My question to you, was our claim the null or the alternate? The alternate, the HA, right? So when I come back over here and I say, look, my claim is my alternate, and we fail to reject the null, then we're going to say there is what? There is not evidence to do what? To support the claim. So right here we're going to say there is not enough evidence to support the claim. The only thing that we did different, guys, in this problem, in the ones we did Tuesday night, like the one we did before, on the one we did before, remember how they gave us the alpha, right? So we knew that this little area here was 0.05. What we would do is when we would find this number here, then we would find the probability going that way, right? And then we would compare those two numbers. Instead of us comparing the probabilities, what we're comparing now, guys, we're comparing the z-values. That's the only thing that we're doing. So instead of us having to find the probabilities, if we know the z-values, we're just going to say, here's that critical value. Is it going to fall this way, or is it going to fall that way? That's all we're really doing. Okay. Look, let's try another one. We got one more like this. And let's see if we can figure this out. All right, so number 10 says, a researcher claims that the mean cost of raising a child from birth to age 2 by husband-wife families in the United States is $13,960. Okay, so I'm going to stop right there. I'm going to say the mean, which is mu, right? The mu is what? 13,960, right? Okay. What's the opposite of saying it's equal to that? Not equal to that. So our mu complement is not equal to 13,960, okay? The first one was our claim. That's what they told us. Now, guys, now that we know our claim, do we also know what our HO and our HA is? Okay, which is the HO? The top one, right? And this is our alternate, right? Okay, so now, what?
How would you get that one right?
Yeah, are you going to give us that little formula also?
What formula?
Going to the formula, but the one on the front page.
Okay, so let's see.
Row is,
Oh, that's equal to?
yeah. And then the HA is,
Let's see. Yeah, the idea of,
kind of like the definition of it.
yeah, let me see. Here we go. This part right here?
That one,
Yeah.
Are you going to give us that?
Yeah, I might go ahead and throw that in there. Why not? Let's see. We'll go like this. Boom. There we go. Yeah, I can throw that in there. ¿Verdad? It's the time for giving.
And the hottie of the drug period.
Oh, did you hear that somebody decorated their stuff on November 1st on the HOA? They're making a big deal. They wanted to take it down.
Wow. Great, great. All right, so let's see. Okay, so guys, look, we have that there right now. Okay, now let's see if we can figure things out. Okay, look what it says. A random sample of 500 children. Okay, so what is that telling me? What's that going to give me? What number is that going to give me? My n, right? N is 500, okay? All right, has a mean cost of 13,725. So our x bar is 13,725, okay? And it says assume the population standard deviation is 2345. What symbol is that one? The sigma, those O with a hat, there you go, 2345. Okay. And let's see, and look what it tells us, alpha is equal to 0.10. Okay, so guys, before I do anything else, I got to figure out left tail, right tail, two tail. Which one do I look at? Which one do I look at? Which is the one that tells me to look at my HA, right? Ha! That's the one that's always going to tell me whether it's a left tail, right tail, or two tail. So guys, think about it this way. It's telling me that it's a two tail. So we're going to find two values right there, right? One of them is going to be negative, the other one's going to be what? Positive. Okay. Now, if you remember when we have a two-tailed test, what we got to do is we got to take our alpha number, which was 0.10, you actually got to divide it by 2. So what's half of a diamond? A nickel? Right. Right. Okay. 0.05 here. 0.05. Okay. So now what we got to figure out is what's the area to the left, right? I want to find my critical values, okay? One of them's going to be negative, one's going to be positive, right? Okay. So anybody remember how do we find those values? Turn it on, right? Clear it out. Okay, second bars, we go inverse norm. Okay, and what's the number we're going to put in there? 0.05. Okay, there we go. Close it up. Okay, so negative 1.64. So this is a negative 1.64. Isn't this one going to be a positive 1.64? Oops. Positive 1.64. So far, so good? Okay, guys, just a quick reminder. Remember, in the middle, this is my fail to reject. These here are going to be my rejection regions, right? Okay, now let's go ahead and find our Z value. Now what we're going to do, I'm going to write the formula, guys. The reason why I write the formula every time, it helps me remember it, you know? And again, it's not that I'm not going to give you the formula, right? But some of the problems you can use your calculator. Some of them, it's going to be very specific. Can you find the Z value, right? And show me your work. Show me how you're getting there. You know what I mean? This is why this is the whole reason I'm writing it out, right? I'm not writing it out because I got nothing else better to do. I'm writing it out because I want you guys to write it out también. You know what I mean? I don't want you just using the test formula every time, right? Okay.
This is the route we're going to get 164 again?
Well, no, this is a route right now that's going to give me the Z value, Fred, and that Z value will either be somewhere in here, or it could be over here, or it could be over there, right? And wherever that value is going to fall, right, it's going to be somewhere on this number line. If I fall in between those two, then I know I can fail to reject, right? But if I fall to the right of this one, or I fall to the left of that one, I'll have to reject it. That's called our critical value, right? And so that's why I put them right here. It is a z-score, but it's a z-score that we're getting because of our significance, right? That's right. So guys, notice what I'm doing now. I'm just going to do a little plug and chug here, okay? What is our x bar here? No. What's the x bar? The 13,725, right? 13,725 minus. What is the mu? The mu is 13,960, right? Okay. Divided by, what is my sigma? 2345 divided by the square root of, what's our n? 500. Okay. So guys, remember, you're not having to do as much of this stuff here because all you're doing is you're just plugging the numbers in, right? What am I going to type in first? 13,725, right? Minus what number? 13,960 okay, equals, okay. Now we're going to go divided by, everybody agree parentheses? Okay, 2345 divided by the square root of how much? 500. Close them twice. Okay, and let's take a look at the z value we came up with. So the z value I'm coming up with, guys, if I go to two decimal places, negative 2.24 or 25? 24, right? Okay, so here's our z value, negative 2.24. Okay. All right. Now, what I want to do, guys, is I'm going to ask you a question. Negative, oh man, what happened? There we go. Okay. Negative 2.24. Would that value, let me get a pretty color. Let's go green again. Okay. Negative 2.24. Would that be in between here, to the left here, or to the right? What do you think? The z value here is going to be negative 2.24, right? Okay, so isn't that in our what area? Reject, right? So guys, all I'm going to do right now, excuse me. We're going to say we're going to reject the null, right? We're going to reject the null hypothesis, right? Because I'm in the rejection zone, right? Now, my question to you, is R null the claim? Is the HO the claim? Yes, it is. Okay, so I'm going to come back over here. Look, we're going to reject it, right? And because the HO happens to be our claim, then we're going to say there is enough evidence to what? That's all we're going to say. There is enough evidence to reject the claim. And so we did. Right? Okay, so look guys, let me save it this time.